I don't have an injection transformer. So if you don't have that, a trick, if you don't need a very high insulation voltage, a trick is to use a common mode inductor. Basically, if you have some scrap electronics or something, you can desolder an inductor, and it will in many cases work just fine as an injection transformer. So I have a couple here. I actually don't have their specs at all, so it's I was thinking that in this video I'm gonna measure some key parameters. The first one being inductance. Then I'm also gonna measure the resistance of each winding, and also the capacitive coupling between the two windings. Basically primary and secondary side, if you consider this a transformer, which is what I'm going to use it for. Of course, this is not the intended use, but I think for what I'm going to, but in my case, it will work fine. But let's get going. I have this LCR meter, and I'm going to start out basically zeroing it. That means that, you have these two Kelvin probes, or 4-point probes, and the coupling between the wires. So basically, the way you position stuff will influence your measurements. So a way to minimize this unwanted influence is to go through a little calibration procedure that this system has. So let's do that. So first I'm gonna kind of try to position the Kelvin probes in the position I'm gonna measure in. So it's something like this. I'm gonna connect here and here, and then I'm gonna let it rest on the table. And so basically I'm measuring from, if this was a common mode inductor, I would measure from like input A to output A. So I'm not, but first of all, we need to do an open circuit calibration. So I'm basically just gonna deconnect these, and I'm gonna go through open circuit calibration. And that takes a little bit of time. Of course, this calibration is done at 100 Hertz, which is in Europe, the mains grid operates at 50 Hertz. Yes. I will sweep through some other frequencies also, but the first thing I'm going to measure is at 100 Hertz. This is also the lowest frequency that this meter supports. So let's measure something. Let's take the one with the thinnest wire. Okay. So let's note that up. That's quite a lot. 36.7 millihenry. So and a fairly high resistance. Of course, in this case, where it's operating at 100 kilohertz, it's not the actual DC resistance. That would definitely be lower. Otherwise, this common mode inductor would heat up during like normal operation. So it's definitely due to AC resistance. I will get back to that in another video. So let's change the frequency. let's step to 10 kilohertz. So now the inductance dropped, and the resistance increased quite a bit. So let's say 10. Oh, actually I made a mistake here. That's 100 hertz. So 24.5 millihenry, 66.5 ohms. That's quite significant. Let's change the frequency again, sorry. To 100 kilohertz. That's going to be interesting. That's interesting, it actually went up again. The inductance. So let's note that. And of course the series resistance increased even more. So it's definitely something with AC resistance. So I'm just gonna, to see if it makes any difference, I'm just gonna recalibrate the probe.
Extra mechanical interface which they didn't use. They went for the other two big bolts down there, perhaps. Right, so let's power this baby up and have a quick play around with it. Self-test. Righto. Come on. You can do it. Oh, my OS is running. Come on. It's only an electric load. Self-test. Twiddle thumbs, and here we go, very much in. Now I don't mind the interface, it's not too bad at all, displays the current voltage with 4-digit precision, thank you very much. And we do get, even though this is not the A model, we do get the 0.1 milliamps, at least the display digit is there anyway. So that is definitely 0.1 milliamps, whether or not, it could be, as I said, just a software thing, and it just counts up in tens, and only has 1 milliamp resolution. I don't know. But anyway, it displays our power and our resistance as well. So let's put it in constant current mode. So ranges here, we've got 40 amps and 4 amps. So that doesn't give us, it doesn't change our display resolution at all. Anyway, so that's rather interesting. Our slew rate, our V on where it just switches on that, our voltage limit, 180 volts. It's 150 volt supply, so why it's 180 volts, I don't know. And our constant current limit up to 70 amps. Once again, this is only a 40 amp supply.